Good morning, everybody. It's a beautiful day here in Los Angeles, California. My name is Eli Van Cleve, and today I'm in a park to talk to you about light. As you can see around you, light is what allows us to see everything around us. But how is it that we can see, with what appears to be white light coming from the sun, green grass or brown trees? Well, I'm going to explain that to you right now. Before I get into too many details about light and the light that comes from the sun and breaking it down into what's called a spectrum, or the colors of light that it's made of by using, for instance, this prism, let me first describe to you what light is. So, what is light? Well, light can be described as either a particle or a wave. But in this case, we're going to describe light purely as a wave and not as a particle. So, a wave has three main features to it. First, a wave has peaks and troughs. The peak of a wave is when it's at its maximum or highest point, and the trough is when it's at its minimum or lowest point. We can also define something called the wavelength of a wave, and that is the distance between two peaks or the distance between two troughs, which is the same thing. This is also defined as the period of the wave. Now, each color of light has its own wavelength. For instance, a color green, which is close to the color of grass, is 532 nanometers. That means that the distance between those two peaks of light is 532 nanometers, or 0.00002 inches. On the other hand, a color of red, which is, say, close to a stoplight, the distance between its peak, or its wavelength, is 600 nanometers, or 0.00023 inches, which is really close. And when you see white light, you see all of the light of all of these different wavelengths coming at your eye at exactly the same time. Here you can see all of the different colors that white light is made of from the sun. You can see the reds here at the top. Let's see if we can keep it there. Reds here at the top, it goes down to blue, and it goes down through green and yellow and orange and all of the other colors. So how does a prism break up light? A prism is a piece of plastic that is in the shape of what we call a triangular prism. Now, there's something called the index of refraction, which is essentially a measure of how well light moves through something like air or plastic. The lower the index of refraction, the easier it is for the light to move through it. The index of refraction for air, and consequently vacuum, is 1, but the index of refraction for plastic is actually around 1.5. That means that when light moves from air to the plastic, the light is going to bend. The amount that the light bends depends on the frequency or the wavelength of the light. So red light will bend less than blue light will, and this is why we see a rainbow when we shine white light through a prism. You can see I've attached the spectrometer up to the computer, and this is what this computer is reading right now. Here you have the wavelengths from the spectrometer, and here you have the intensity, or how bright the light is. And here's the fiber optic. So if I take the cap off of the fiber optic so it can look around, then you get the spectrum of all the light that it sees around. Now, some of it changes a little bit depending on where I'm pointing, because some things are, say, more green, which is right here. This is a little bit more yellow up here. Here's more blue. So this is kind of looking at the blue sky. So you see a lot more blue, which is down here, and a lot more yellow whenever I start focusing on the ground, a lot more green when I start focusing on the ground and the grass. So it depends a lot on, this is very much the same way that your eye might sort of see things. It's not exactly the same because your eye is not a spectrometer, but isn't this neat? This is what the world looks around us if you were to break it all down into the wavelengths of light. These are all the separate little pieces of wavelengths of light that, in fact, you're looking at right now as you're staring at the computer. And I can even point this at the computer, and here you can see it. Here I can point this at the screen, and you can start seeing a lot of the blue from the screen. I can point it down here at the computer here, at this logo, which is red. You see how this red logo right here? You can see a lot of red light coming from it. And so you can see how this thing is exactly seeing whatever I see. Here it sees green from the screen. Here it's going to see a lot more white and a little bit of blue. And here it is just staring right back at you, and that's what it sees. Thank you so much for coming on this journey today with me. I hope you all learned something new. If you liked this video, please subscribe to my content and have a wonderful day. This has been a video from Van Cleve Scientific. If you like this, please like and subscribe for more content.